will be recorded for learning purposes, yours as well as others. Okay. So, hello. I had a workshop yesterday and I was a little sad. We only had 5 people show up to work on their exams. The people that did come did a great job. But I will have another workshop next week, and I hope we get a little bit more attendance on that. And might kind of change it up and make it required for those people that have not completed their Unit 1 exam or failed it. Okay. So anyways, that will be coming up next week. But if you need help or want help on anything, whether it's the exam or something else, let me know. You've got my information. It's at the top of the webpage, as always. Today is Wednesday, September 4th. And we're going to do notes. We're going to talk about friction and gravity today. Tomorrow, remember, is an asynchronous day, right? So it is a work day. You can work on your Unit 2 exam, but it is not due until September 19th. I have 7 people who have turned it in. And if you are one of those people that submitted your Unit 2 exam, I would really like you to unsubmit it, because I don't think you want me to grade it right yet. Okay, you would not get a good grade. So don't submit it. Hold on to it until we cover everything. Okay. And then on Wednesday, we will come back and do another set of notes. Okay. So we are still very, very early into the Unit 2 on motion and forces. Okay. And that exam, again, is not due until September 19th. Today, we're going to be talking about gravity and normal force, applied force, and friction force, both static and kinetic. And we're going to look how we can diagram these things on a graphic organizer for us. So go ahead and open up your notes, okay? Give me a thumbs up once you have those notes and you are ready to go. Thank you, Kura. Thank you, Becky. I appreciate you. Thank you, Tatiana. Thank you, Jenna. Rylan, thank you. Emily, Errol, thank you, thank you. Thank you, Grace. Thank you, Pacifico. Angelica and Brittany, Sierra and Riley, thank you. Jalea, thank you. Awesome. Okay, I think we're good. Awesome. Okay, so I have a video for you and a bit of a challenge. Okay, I want to know if you've done this before, and how many how many pennies you've done if you've done this before. You ready? Okay, here we go. Okay. So has anybody done that before? Anybody? Let me know. Drop it in the chat box. No. Nobody's done this. I'm so sad. Why would you? To see how many pennies you can get in the cup. Yeah. It's oddly satisfying. It really is. I had somebody, you would never. I had somebody in first period that did it, but not with a note card and a glass of pennies. They used like a sheet of steel and had this pendulum. It was crazy what they did. Yeah, I'm just a nerd. I can't help it. But yeah, okay. So with that demo in mind, okay, tell me this: what is trying to pull the penny down? What is that? What is holding that penny on the note card? Excellent. Yeah, gravity. Excellent. Absolutely. Yeah. What's preventing the penny from falling? A force, Brittany. The paper. It's a force from the paper, right? Exactly. Exactly. And then why did the penny fall into the glass when that note card was removed? What pulled it down into the cup instead of flying sideways? The pull of gravity. Exactly. Yeah. So you guys already know most of today's lesson. Okay. You already know most of today's lesson. So gravity is an attractive force between all objects. Okay. If I hold up my phone and a pen, right, there is a attractive force between these two objects. My phone is heavier than my pen, so my phone extracts a yeah. I don't know what's going on there. But what is the largest object of all in our habitat ecosystem is the earth, right? The earth pulls all objects towards itself with that attractive force. And that's what kind of keeps us on earth, right? And this force also, when we apply it, and the force due to gravity, due to earth, on earth, we label that as weight. Okay. And this is something that can really confuse a lot of people. Always remember that mass does not factor in weight. Does not factor in gravity, but weight does factor in gravity. So mass and weight are very, very different. When I step on the scales, okay, the scale factors in the force of the earth pulling on me, okay, and I can measure that, and the units that we use in the United States is pounds, okay. But in the metric world and in the science world, weight is measured in newtons because it's a force, okay. So always remember, mass and weight are very, very different. Okay. Question number 2 is attractive. Okay. Attractive. remember that spelling counts. So go ahead, complete question number 2. Let me know when you are finished. Okay. Let me know when you are finished with question 2. Thank you, Angelica. Thank you, Errol and Emily. Thank you, Pacifico, Jenna. Sophia, thank you. Joseph, thank you. I appreciate you. Awesome, awesome. Kura, thank you. Awesome. Perfect, Christina. And Sierra and Julia, thank you, thank you, thank you, thank you. Okay, so the force of gravity, when I start adding these vectors on my diagram, the force of gravity, because the Earth is the largest object in our environment, the force due to gravity is labeled with this arrow pointing down. And notice that that the force is represented with a capital F and then a subscript G. Okay. So that represents the force of gravity pulling the penny down. Okay. Now there is also a normal force working on that penny. Okay. And the normal force is the support force. Okay. We said that there's a force from the card pushing up on the penny that's supporting the penny. And that is the normal force. It is always, 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 always perpendicular to this surface. Okay. Some or all of the normal force works against gravity. It's in the opposite direction. Okay. It is in the opposite direction. Okay. Awesome. 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 Thank you, Sierra. Okay. Everybody else, you good? Thank you, Grace. Angelica. Kata, thank you. Thank you, Sabrina and Becky. Pamela, Maddie, Jenna, Pacifico, Kura, Rylan, Joseph, Michelle, thank you. Jennifer, thank you. You guys rock. Christina, thank you. Okay. So that was question 3. So I can draw this on the diagram as well. Notice again, it's capital F, which says it's a force. And it has a subscript N indicating it's the normal force. Now, I want to show you and point something out here, okay? These arrows are called vectors, okay? And notice that the vectors are equal in length, okay? The reason why they're equal in length is that they are equal in strength, equal but opposite, okay? Equal but opposite. Okay, so always look at the length and shape of the vectors, because the vector is going to tell you the magnitude, how strong the force is, as well as the direction of the force. Okay, I love that you guys support each other. That's awesome. A third force that was acting on that penny, okay, is the applied force. And this one actually was working on the card, not the penny, okay? An applied force is any push or pull on an object that is going to cause something to move, okay? Once it overcomes friction, okay? So an applied force. So when you flicked that card, or in the video, when that card was flicked, it overcame the friction on the glass rim and caused the card to shoot off the glass. Okay, so that's an applied force. And again, you can see it's represented with a vector, right? It's going to the right, which means it's positive, right? And you can see the magnitude or the strength of the force by how long the arrow is. Okay, awesome. Okay, now friction opposes the motion of an object on a surface. Okay, friction is super important. People don't give it enough credit. It allows you to sit at your computer, to type on your keyboard, walk across the room, turn the page of a book, all the things, right? Now, it also, though, makes things harder to move, right? Okay, because it's opposing that motion. Awesome. So let me know, thumbs up. You good? Awesome. Thank you. Good, good, good. Adrian, you good? Antoine? Francisco, how about you? Are you doing okay? Awesome. Perfect. Okay. So now I've got the friction on the diagram now. What do you notice? And I want you to drop this in the chat, okay? Darwin, your face is amazing. What do you notice about the vector for force compared to the vector on the applied force? What do you notice about those two arrows, the vectors? Okay, what do you notice about the vectors, the length of those arrows? Tell me. Are they both? Which one is shorter? The friction or the applied arrow? Which one's shorter? The friction is shorter. Excellent. Good job. Yes. Excellent. For sure. And so that means that the card's going to move. If they were equal, then the card wouldn't move, right? But because we can see that the vector or the arrow is bigger than the friction, I know the card's going to move towards where that force is being applied. Okay? Make sense? Awesome. Okay. I am trying to respond. Okay. Okay. That was supposed to only go to Michelle. I don't know what happened there. Michelle, stay at the end of class, okay? And let me help. Okay? I'm sorry it went out to the whole room. I'm so sorry. Yeah. Okay. Friction. Okay. There's two types of friction. There's static friction, and static friction prevents objects from moving. It is what makes it so hard to move things. Okay. Has anybody noticed that when you're pushing something really, really heavy, it's harder to get it started, but once it starts moving, it becomes easier? Has anybody noticed that? Yes? Yeah. It's static friction when you're trying to get it started. That's static friction. Okay. And then we have kinetic friction. Kinetic friction is that little bit less force that's, I mean, it's still hard to move, but it's a little bit easier, right? So static friction is this force that's so hard to get things moving. But once it starts rolling, then it's kinetic. Okay. Okay. Awesome. So now I've got a video. Okay. I've got a video for you guys. Let me close this out. Okay, this video, I'm going to show a couple videos from this guy. His name is Bobby. Okay. And Bobby, he is a physics grad student. And he teaches AP physics, and he teaches some college level. Okay. So his videos, he's sort of a dweeb. He is a nerd, but they're kind of funny. And I think it really, really helps. Okay. You see some of this in action. Everybody missed question 6. Okay, let me go back to question number 6. Okay. There is 5. Oh, we haven't done 6 yet. That's why you haven't done it. We haven't done 6. Okay. So let's watch Bobby. Okay. We haven't done 7 either. Yeah. Okay, I'm going to pause this for just a second. Notice that the vector that Bobby's holding right now, what do you notice that's different between that vector sign and this vector sign? What's the difference between that's there? This one versus that one. What's the big difference between those two signs he has holding up? The size, yes, the size. So when he's putting pressure on it, he's increasing the force of friction. Okay, so that's Bobby. We will be seeing more of Bobby. Okay. But that sort of explains static and kinetic friction much better than I could. Okay. Now, here is question 6. Okay. Ryland says that the order that the words go in is static and kinetic. Okay. Let's plug those in and see if everybody agrees. Okay. Static friction prevents the object at rest from starting to move, while kinetic friction resists the motion of an object that is already moving. Do you guys agree? Yes? Yeah. Yeah. I agree too. I agree too. Perfect. Yes. It is static and then kinetic. That is question 6. That is question 6. Excellent. So give me that thumbs up. Let me know when you have finished question 6. Awesome. Party, 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 party. Okay, question 7. Okay, I'm going to give you 30 seconds and I want you to label each one of these forces. A, B, C, and D. Label them, what type of force it is, and then we're going to come back and check. Okay, so I'm going to give you 30 seconds to do it on your own. Okay. So now, you have access to the annotation tools. What is A? What is A? What is force? What type of force is A? Okay. So normal force is being pushed up. Good. Okay. Applied force is B. Excellent. Excellent. Okay. Which one is gravity? Yeah, gravity is C. And then you've got friction, which is D. You guys are on fire. On fire. Awesome. Yeah. You guys rock. Okay. So, how do you feel? Okay. We talked about gravity. We've talked about normal force, applied force, friction force, and we looked at vectors on a diagram. And we can tell if they are, if they're bigger, we know the force is larger, and we can determine the direction of the force as well. Okay. So if you are feeling good, okay, and you are over here, you can submit it and turn it in. Okay. Michelle, hang out. We're going to chat at the end of class. Okay. Ryan, hang, and I'll do 2 and 3. Okay. And whoever is very, very confused, hang and stay, and we can chat. Okay. Okay. Awesome. 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 Bye. Have a great day. Have a fabulous, fabulous day. Bye, Grace. Bye, Jalea, Pacifica, Sabrina, Rylan, Pamela. Okay, Angelica.